My name is Priyanka Third. I am the lecturer of Electronics and Telecommunication Engineering. I am going to study about pin configuration of 8085 of microprocessor and microcontroller subject. And this is the pin configuration of 8085 microprocessor. These are the pins of microprocessor, that is the 8085A, where 40 pins are there, and each pin has his particular designation, or there's some characteristic which is attached to the pins. Here X1 and X2, that means these are the crystal oscillator which is used to generate the frequency that is of 3 MHz, which is coming from the 6 MHz, which is divided equally in two halves, that is 3 MHz and 3 MHz, and this is also generate the frequency which is generated for timing diagram of the program when we execute some program. The next is the reset in and reset out. The reset in and reset out. The reset in and reset out. The purpose is to reset the device which is connected with the microprocessor. That reset in connects the peripheral device, and reset out also connects the peripheral devices. Reset in means the microprocessor, the computer again converted into zero, or it display the zero output. This is both same for reset in and reset out. It is used to compatible with the peripheral device with the 8085 microprocessor. That means here it is used to reset the microprocessor. That means reset means it set to zero, and it is active, and it is an active low signal, because there are two signals used in 8085 microprocessor. One is active high and other is active low signal. Active low signals are represented by a bar. Then when the signal on this at least 3 clocking cycle of the microprocessor to reset. That means when the 3 clock pulses are low, then the reset in and the reset out operated, because this is the active low signal. And the next is pin number 36 and pin number 3. Next, clearing the some data that we are there. The PC and IR. PC means program counter, and IR is instruction register, which carries this reset in and reset out, and it is also used to control the interrupts, because when we mask the signals in SIM, set interrupt mask, we use this reset in and reset out signals. So it is also used to disable the SOD pin. SOD means serial out data line. SID and SOD, these signals are used also for connection of 8085 microprocessor with the peripheral device through 8255 IC, 8255 IC, which is the peripheral interfacing device, which is used to connect other devices or peripheral devices with the 8085 microprocessor, because we cannot connect the peripheral devices with microprocessor, 8085 microprocessor directly. That's why we used 8255 IC. Here trap is which has the highest priority, and it is also non-maskable. The next is the same reset out. Reset out. It is used to reset the peripheral with the IC on the circuit. It is an output signal, where reset in is an input signal and reset out is an output signal, and it is active high signal, where there is no bar. That means it indicates that it is an active high signal, where the reset in is an active low signal. The output on this pin goes high when reset in is given low signal. That means when reset in is low, then reset out is high. And the next is SID, serial input data. SID and SOD. Both two signals are used for data connection when peripheral devices are attached with the 8085 microprocessor. Here 8255 used to interface the peripheral device with the 8085 microprocessor. So it takes 1 bit input from from 8085, then stores the bit in the 8th of the accumulator. Then by using read instruction, we can operate the SID signal. And the next is SOD. SOD means serial output data. It is also used to interface the peripheral device with the microprocessor using 8255 IC. So it also takes one bit from the accumulator, and then it takes the bit from the 8th bit, that is the 8th bit, that is the most significant bit, MSB, and the 0th bit is the LSB, that is the least significant bit, where it takes the bit from 8th bit of the accumulator, and it is operated using SIM, where SID is operated with the read instruction, read interrupt mask, where SOD is operated with the same interrupt mask, where it is used to transfer the bits. The next is interrupt. So we are saying most of the time that interrupts are there. What is interrupt? That means interrupt is an intermission. Intermission means it means interrupting the normal execution of the microprocessor. That means when the microprocessor is interrupted, that means when it does some program, but during that another function need to operated by the microprocessor, then it takes the signal as an interrupt. So when microprocessor receives interrupt signal, it discontinues whatever it was executing. That means whatever it executes, the microprocessor holds it. So it starts executing new program indicated by the interrupt signal. That means when it holds the current program, then it jumps to the program which is come across the interrupt signal. So the interrupt signals are generated by external peripheral devices. After execution of the new program, microprocessor goes back to the previous program. That means when the function is completed, then it goes behind the continuing work or current program, and the function was completed and the interrupt goes low. So the next, sequencing. That means when we are interfering or when we have to interact some more than one interrupts, then we have to sequence it. So here there are steps where whenever there are more than one interrupt, we need to follow these steps. First, microprocessor completes execution of current instruction of the program. Then PC contents are stored in stack. That means stack is nothing but the memory location where the information in the terms of data is stored. And the PC is nothing but the program counter, which is a 16-bit register, and it is also stored in the stack. The PC is loaded with address of the new program. That means we have to maintain the PC as the task member. PC holds the memory location to be executed next, where stack pointer holds the current program memory location, and the PC holds the next program memory location where to be executed. After executing the new program, the microprocessor returns back to the previous program, and it goes to the previous program by reading the top value of stack. Then the next performance or mark has to be completed by following the stack of the memory location. And the next, 5 types of hardware interrupts in 8085. That means here interrupts are categorized into 5 types. First priority or highest priority goes to the trap, then RST 7.5, RST 6.5, RST 5.5, and the next is INTR. Where it is also classified into 2 types. One is maskable and other is non-maskable. It is classified in 2 types. One is maskable and other one is non-maskable. Maskable means we can handle it by putting 0 or 1, or by enabling or disabling the bit. We can call it maskable. Where we cannot interact or the output is confirmed, we cannot manipulate the 0 or 1, then it is called non-maskable. This is the next. Maskable means the interrupts are those which can be enabled not disable or enable, it's called non-maskable. The next slide. The next slide shows the non-maskable interrupts, where the interrupts which are always in enabled mode, that means it is enabled by the system only. We cannot manipulate this. These interrupts can never be disabled by any software instruction. So trap is a non-maskable interrupt. Only one non-maskable interrupt is there, that is the trap. The next.
MTK.
The next is pin number 8, which constitute the RST 6.5. RST means reset or restart. Here 6.5 is assigned by the microprocessor by its both memory location position, and it is a maskable interrupt, so it has the third highest priority, and it can also be enabled or disabled by EI instruction, that is enable interrupt. EI stands for enable interrupts. The next is pin number 9. Pin number 9 is RST 5.5. RST also stands for restart or reset. 5.5 is also assigned by the memory location, and it is also a maskable interrupt, and it is the fourth highest priority, and it is also a label triggered. All the interrupts are here label triggered, and this interrupt is very the next address and data pins. Then the next one is the address and data pins. Address and data means here the pins are address in the pins diagram, where address and data is here we are using 8-bit, where address is 16-bit, and the data bus means it is used to transfer data between microprocessor and memory, and data bus is of 8-bit, where the next here we can recognize the 80 to 87. That means here the lower address of the address and the data is combined and multiplexed to represent both address and data. That is 80 to 87, which is represented by the pin number 12 to 19. Okay, and this pin serves purpose of transmission order address, and during the first, this can be explained in timing diagram, where the fast clock pulse by using the address latch enable, it can be demultiplexed, where the address and data can be separable. The next is here pin number 21, to 28. These are the address line, where this is the higher byte of the address, and it is the unidirectional. Data, or sorry, it is the unidirectional in nature, because only microprocessor can assign by the start or the memory location where to be executed or where to be functional. So it is unidirectional in nature, where the data is bidirectional in nature. Then ALE, which is used to demultiplex the address and data of 80 to 87. This is address latch enable, where it indicates whether bus functions as address bus or data bus. When AL equals to 1, that means address and data can be interfered. That means bus function acting as an address bus. When AL equals to 0, we can consider the 80 to 87 bus as data bus. When it is 1, we can consider it as address bus. The next one is pin number 29 and 33. These pins are used for S0 and S1. S0 and S1, these two are the starter signal which show the programming or what kind of program is done by the microprocessor. It is also indicated by S0, S1, and its operation is there. When S0 and S1 bit is both are 0, that means halt operation. Halt means nothing. Halt means it is hold. It is one kind of hold signal. Then 0, 1 means when S0 equals to 0 and S1 equals to 1, the write operation done by the microprocessor. When 1, 0, it is a read operation. When both the values are 1, then it is a opcode fetch. Opcode fetch means when we have to execute a program, the first cycle is the each operation, which is denoted by this S0 and S1, both are 1. Next is I0 M1. I0 M1 means the 34 pin. Designed by denoted by 34 number pin. I0 means the microprocessor is an input output device and memory. Input output device means I/O device and memory means memory. Because the microprocessor or accumulator has to communicate both the memory and I/O. So at a time it cannot be communicated with the I/O and memory. That's why when I/O is active high signal, when it is high, that means the microprocessor is communicated with the input output device. When this signal is indicated by the 0, that means the microprocessor is communicated with the memory device. Then next the pin number 34, the operation being performed is indicated by S0 and S1. That means here the S0, S1 and I/O M bar. I/O M bar means both has to be accumulated to, or both has to be represented to explain the execution of the program. So we need to know the I/O M bar status, S0 and S1 status, so we can study the read, write, halt. Those kind of operation is done with the I/O or memory. When I/O/M bar on the values are 0, that means the device is in memory, and with the signal it is same. So opcode fetch, that means I/O/M bar 0, 1, 1. It indicates that it is a memory operation. Memory read means 0, 1, 0. 1, 0 which is used to read, and 0, 1 is generally used for write operation, and this 0, 0 indicates the memory device. And I/O here 1, 1 is there, and 1, 0 is for read operation, and 0, 1 is for write operation. And interrupt or acknowledgement, when all the signals are in high, that means it represents that there is an interrupt. And the next one is the halt operation. When all the values are 0, that means S0, S1 means 0, and here 1 means it is a input device, output device halt. When 0, that means it is a memory halt operation. So the next is here RD bar. RD bar indicates by the pin number 32, and RD means RD stands for read operation, and it is the active low signal. We generally know that when the signal goes low, it is operated. So it is a control signal used for read operation either from memory or from input device. The read operation can be memory or can be I/O. I/O means input output device. A low signal indicates that data on the data bus must be placed either from selected memory location or from input device. So here low indicates that there is an operation, or which kind of operation? It is a read operation which is done by the microprocessor when it reads the data from input or input output device or memory. So the next one, WR bar. WR bar means it is a write operation which is also a low signal or active low signal. It is also a control signal which is used for write operation either from memory or from input output device. So a low signal indicates that data on the data bus must be returned into the selected memory location or into the output device. That means the low signal of the data bus, which location is selected, the selected location must be written into the microprocessor. So the next one is ready signal. Ready means when the computer or the microprocessor is in operation state. We indicate it by a active high signal. So when peripheral device is attached to the microprocessor and the microprocessor is ready to work with the I/O device or memory, it indicates by the ready signal when it goes in high signal. Then that means the peripheral is doing fast with the microprocessor, and the low signal hold. Hold is a kind of operation which is done during the interrupt operation. That means when the current program is running, at that time we have to quite halt. Quite halt means we have to hold on. We have to stay at that point. It is also a high active high signal, and this is used for DMA controller. DMA means direct memory access controller. When we are not using any peripheral interfacing device and we are contacting with the DMA device which is 8257 IC, then this hold signal is used. And 8257 is nothing but the DMA IC. The next one is HLD, where hold is the operation, that is the hold kind of, it is a constant, or there is no change of the operation. And the hold acknowledgement means the hold is continuing, is knowing us by this hold acknowledgement signal. That means this acknowledges the peripheral device or the read, write and IOM bar signals. That is the accumulator is in the operation is in the interrupt signal, or it is staying hold the current program and it is going to the another program. And the next is VSS and VCC. VSS and VCC, which is the very essential point of the IC or microprocessor. That is VCC is the plus 5 volt, or it is the supply point, which is the plus 5 volt, and VSS is the ground point. Okay. Then next.